Hello everyone, welcome to today's speaker session, Introduction to Machine Learning. Prepare yourself for an enriching and insightful experience as we delve into today's topic, which revolves around machine learning. Machine learning is a branch of artificial intelligence that focuses on the development of algorithms and models that enable computers to learn and make predictions or decisions based on data, without being explicitly programmed for each task. In simpler words, machine learning is like teaching computers to learn from examples. Instead of giving them specific instructions, we show them lots of examples and they figure out patterns on their own to make predictions or decisions. Throughout the session, we will delve into machine learning fundamentals guided by our esteemed speakers who will help us to uncover the secrets to pouring our paths into the world of machine learning. With this, let's dare to shape the future starting now. If you have any doubts, please drop in the comment section. They will be discussed later on. Let us extend a warm welcome to our machine learning enthusiasts, Mayank Goswami and Suraj Paliwal, as the speakers and let them impart their knowledge and offer guidance to our audience on initiating their machine learning journey.
Hello everyone. I'm audible.
Yes.
Hello everyone. My name is Mayank Goswami, and I am currently working as a data analyst at EY, which is one among the big four firm of the current industries for the consultation and the law and the tech consulting. So today I'm going to present you the basic introduction to machine learning algorithms, and I request the Suraj Paliwal to introduce himself.
Hey everyone, my name is Suraj Paliwal. I am a student of Dronacharya College of Engineering. I am currently pursuing my Bachelor's of Technology and in final year. And now I am currently working as a research intern at Kyushu Institute of Technology, Japan. And today here me and my friend Mayank will be going to give you a short description about machine learning so that other enthusiasts of machine learning can join in. It is just a completely beginner session. So anyone can join for beginner session, and as the session proceed, we will just increase the hands-on practice and some more things in our session. So let's start our machine learning session. Next slide. So everyone, as you all know, that machine learning is a subset of artificial intelligence. So first we will just try to learn that what is artificial intelligence. So artificial intelligence is a branch of computer science and electronics, as you all know. And in this, we just deal with making the machines smarter or intelligent. And now you all are thinking that how a machine can be smarter or intelligent. So a simple machine is just like your clock. If you see your clocks, so that it is just only a simple machine. But when we talk about clocks with Google Assistant or voice assistant system, then it's a smart watch or smart clock in which there is our Google Assistant, which will help in customizing our day, and it will help us to interact with AI, with it, and help us in making different things. So now my friend Mayank will give you a guidance on how machine learning is a subset of artificial intelligence.
Okay, Suraj Paliwal. And machine learning is basically a technique to implement the artificial intelligence by utilizing the data, as the machine learning requires the lots of data. It's tons of data to train the models, and based upon the prediction value, we get it as the output. So that's all. And next slide. Now we talk about the life cycle of machine learning. So first thing about the first phase of the life cycle of machine learning model is the gathering of data. Means There are the various sources on the internet that we can gather the data about different type of, like for example, the data set of a plants and the types of plants, data sets of the pets and animals classification. So that's all about the gathering the data from the internet sources. And I would like to like Suraj Paliwal to explain
Yes,
about
yes,
data
yes. And
preparation.
then we have, as my friend Mayank has said about gathering of data, we have a lot of data in our modern world, and we can say that everything which is on internet is producing a data itself of its own, and data is just only the raw MBs which can be generated just by your logging in or logging out from a website. And that's why it is necessary to do data preparation, so that we need to filter out the data which we need to evaluate, or sometimes in the data which we had gathered there are some empty values or repeated values which are not that much helpful for our other further concentration. That's why we use data preparation methods. And now about data wrangling, Mike will help you to guide.
Data wrangling is the process to clean the value. Means the data which we have gathered from the different sources might contain some missing values or something data which might not follow the trends. So data wrangling has further 5 steps. For example, like missing values, and there can be a presence of outliers. So we have to clean that part of the data to train our model efficiently and get the required outcomes. I
And
will like
such after data labeling, we have data analysis. And data analysis part, we have different types of methods like exploratory data analysis and some more other different type of data analysis method, so that we can see that what is actually happening in the data. And there is a common term which is called information. So we can say that from that raw data we are processing some information by analyzing data. As we all know that you, if you will see tables in Excel sheet format or in some other files, you will not know that what is the meaning of this data or what is not. And similarly, if you see that all in form of graphs or in form of other helpful things, so you can know that you can know or you can interpret that data and can gather some information. So similarly, after analyzing the data, then we get some fields or filters on which we need to work. And like if you have a data set of your childhood diseases, that how many times you have been you are sick during your childhood, so you can just filter out some fields like ages, like your age, like that time which is the main disease which is which is in common that time. And then you can take all those fields and then you can then filter out some data. And then you can we will just take any data set, and then after doing the data preparation, data wrangling and analysis of the data, we will just split the or data set into two part, which is a train and test model. In this we will just took some of the data to do the training or training according to our machine learning algorithms. So it is just like if you think of a hypothesis, then you just divided your data set into two parts of training and testing, and you will do some training on your uh, half of the data, and then you will test that the hypothesis which you derived from the training of your half part is applicable to the rest part or not. And then in the last part of machine learning life cycle, we have the deployment process, in which we will deploy our machine learning algorithm on the web so that it can be used as an API. And here my friend Mike will help you more about it.
now coming over to the training model. Once we analyze the data efficiently and gather out our feature extractions, means what all columns we have required to build our model accurately. So now coming over to the training model. Training model have further classification of machine learning, like there are supervised learning algorithms to train the model, classification and reinforcement. So in regression, there are few models like linear regression or the random forest regressor to train our model. And regression work for the continuous variable. And similarly for classification, we have the categorical values, means they are the category divided, like for example, the gender of the person, which can be a male or female, is a classification attribute. Now, once we have trained our model, we test it on to the rest of the value, as the Suraj said, and later on we can deploy our model onto the as a API or the backend services. So now move on to the next slide. And these are the some application of the machine learning. Means automatic language translation is the NLP task of the machine learning algorithm, in which we train our text model based upon the currently like LLMs and large language models are used for NLP task. Medical diagnosis, stock market trading. This is the example of the regression model. Online fraud detection. This is the classification model. Virtual personal assistant, email spamming, self-driven cars. Like the most beautiful example of the AI implementation is the self-driven cars. For the product recommendation system, we have using the association clustering algorithms, traffic prediction, speech recognition, and the image recognition. It requires all the deep learning skills like conventional neural networks and the rest of. So this is all about the application of machine learning. Now I want Suraj to explain the types of machine learning algorithms.
Yeah, so as my friend, I've told you that machine learning is a technique to implement artificial intelligence, and artificial intelligence is just something like introducing intelligence to a machine. So it is a curious question that how we will introduce the artificial intelligence to a machine, and machine learning will help us in doing that. And in machine learning, we are just making machine so much smart that they can, without being explicitly programmed or being programmed by someone else, they can determine what they are doing. So it is mainly of 4 part, which is supervised, unsupervised, semi-supervised, and reinforcement learning. So I will just start with firstly with supervised learning. So can you please change the slide? Yeah, so in supervised learning, we will just label the dataset. It is just like if you are giving a computer machine algo, that this in this dataset we have give the pictures of different side, taking the picture of different side from of an apple and giving it to the machine that this is an apple, and then giving the images of oranges, that this is how the orange is, and giving different features of oranges and different features of apples. So in this, we as an user, we as a programmer, we are helping the machine in telling them by labeling the data set that this is apple and this is orange. And if we will give them a third unidentified object being apple or orange, then the machine is that much self intelligent that it can tell us that what is an apple or an orange. And so that's all in supervised learning. And then unsupervised learning. So unsupervised learning, in this we didn't have a labeled data set, or we can say that we just didn't tell the machine that which are the features of an apple or which are the features of an orange. It will automatically from our data can check out for the similar features and club them into one similar thing. That if the apple is like red, so it will check for all the red colors things, and it will just make it an apple. And for orange, if it is an orange color, then it will just club for all the orange color. And then the machine will predict that the object which we are providing them, is it an apple or orange. Next, semi-supervised learning. So in semi-supervised learning, in it, as we have already explained you about the train and test model. So in it, we will train the data set in form of supervised learning, or we can say that we will train the data for apple and oranges by telling them that this is apple, this is orange. And we will then try to give a third different object to the machine so that it can tell us, is it an apple or an orange or something else. So basically, is semi-supervised learning is a combination of both the learnings, and next we will go to reinforced learning. So basically, reinforcement machine learning is a process in which an intelligence agent takes action in an environment to maximize its reward. Or you can say it is like just you have seen the computers playing chess or computers playing go games. So you can take here the go game or the chess as an environment, and your computer which is playing as an agent, and all the actions which it is performing, like moving of rook, pawn, or any other piece on the chessboard, it is just like an action, and we will design a reward for it. So basically, this is the basics about the reinforcement learning. Now my friend Mayank will help you explaining about the supervised learning parts, as supervised learning is subdivided into two parts: classification and regression. So my friend will start with classification first.
So as I later said that classification have the categorical values, means we can predict the what categories will be divided into. For example, male, female, red or blue, and yes or no. So how to machine classify it? So first of all, it will draw a regressive line to classify, means above the regression line is the one category and below that is the second category, class B. So what are the implementation of the classification? So classification algorithm I use for the spam detection, give whether the text containing the text which we have got in the email is a spam or not, based upon the NLP technique which we have applied. And based upon that technique, they classify as the means whether the image is a spam or not. And similarly for email filtering task, means if you have to filter the email based upon the job description. So here the text model will work and all the job description tasks will be classified as class A and rest are class B. So that's how the classification algorithm works. Now moving on towards the regression. So regression is basically a linear equation like which we have studied in school. For example, the y is equal to mx plus c is a basic line equation in which x is a variable and y is a variable, and both are continuous variable which have some intersection line. So the different data set are plotted and the regressive line is passed through them in such a way that there will be a lesser number of errors. And how the error are calculated in regression is the mean squared error. Means all the points which you can see among the regression lines, their distance from the line is calculated, and based upon that distance and summing of all the distances from the regression lines, we evaluate the mean squared error. So based upon that, the evaluation of the regression is took place. Means our regression model is predicting it what will the score of the prediction percentage value. So I think that's all for the slides, and I will like to move towards the hands-on.
So as my friend is moving on to hands-on, I would like to discuss more about machine learning or machine learning. And as you all know that in today's world there is a good generation about the generative AI, or generative AI is in too much talk nowadays. So as we have or previously said that there is different subsets of artificial intelligence, like machine learning is a subset of artificial intelligence, and then we also have deep learning as a subset of machine learning, and similarly generative AI is just also a subset of deep learning. So if you need to dive into machine learning, you can see many different things in it. And here we will just in 1 2 minutes we'll start with a machine learning basic classification model, in which we will classify the Nasik weather, so that during a day how the weather it is being classified. It's a multidisciplinary classification model.
Is my screen is
So
visible, Suraj?
yeah, yes, you can start.
So So this is the basic classification problem, like last weather. We have to predict the weather. So now moving on to the means we
And
look at
here
the
we are
data.
using Kaggle platform, as you know that in Kaggle you can find some data sets and easily find data sets which are being data cleaned and data wrangled also, so that you can directly use them for any of your data analysis or other things.
Here's the
Here the
location.
Kaggle has already splitted the data into training part and testing part. Basically, it is a challenge in which we need to complete, so that we can check that how much is our model is overfitting or underfitting. And that's why my friend is showing you in a challenge. First he has loaded the training data, and now he's also loading the test data.
So first we are printing the training and test values, all the 5 rows, to see the data on which we have to work upon. As you can see that we have to predict this weather condition, which is a categorical value, clear day, or it can be partially cloudy, or it could be a rain. So these are the three categorical values.
Yeah, so it's a quick revision that in classification we will try to classify into some groups, that whether our result will be in which group. And here, as seeing the head section, we can see that there are mainly three groups, which are clear sky, rainy, or partially cloudy. So, and now here just check the info of our data set, that if we have a null value or not, or something like that, because it is recommended that we must eliminate the null values and try to lessen the duplicate values.
So it contain the wind gust contain the 7 null values. So we have to get rid out of it. And similarly, we can check in the test data, is it contain any null value or not. Yeah, and wind gust it contain the 2 null values. So, and now moving on to the means, what should we do when we have a missing values? So there are some few techniques, like if the data contain more than the 50% of the missing value, you are good to drop that column. Means it is a general consideration. Now, since the wind gust contain, here is the wind gust column here. So since it is a numerical value, means the data type of the wind gust is floating point. So we can use the mean of the wind gust. So in the wind gust column, here we are going to get the mean value. So is my screen is visible, or is there some?
Yes, yes, it's visible.
Okay. So I will get the wind gust. and I will fill the null value with the mean value. So that's how we'll tackle the missing values. And similarly for test data also. Just we see that I will check is the null values are removed or not. See, the null values is removed from the Wincast as it gets filled with the mean value. Now think, what if the category value have null value? Then in that case, we can use mod because there the mean does not work for the categorical or text value other than integer or floating point data type. Similarly for the test data, sorry, for the test data. See, for the train data and test data, we have removed the null value successfully. Now we'll look out for outliers using box plot. First, we have to import some library like matplot. Suraj, you can explain about the library as well.
Oh, yes. I will explain. Here in Python, there are different libraries which are used for different purpose. So in it, my friend is using Matplot and Cbon, and so Matplotlib is a library in Python which is enables the user to generate visualizations like histogram, scatter plots. Basically, he is just analyzing the data, that how the data is going, and so that it can be helpful for him. And Cbon is an advanced version of Matplotlib. You can say that it is also a visualization library which is being built on Matplotlib, and it gives us more refined data visualizations. Yes.
Sorry. For training data, we will get all the columns, and I will plot. Now I have to mention the kind that we have to do box plotting. Oops. Or we can just remove it. So we have got the various box plot, and we have to resize the graph. Science. Hmm. So is the table is visible? The box plot?
Yes, yes, yes. The box plot is visible.
Yes.
I think it will be good if you will give them some insights that what is the box plot is telling, so that they can know that after doing the analyzation of our dataset, then we are able to determine which model we will be trying to solve the problem. As the data, it is a raw data, it is too much, and after visualizing the data in different parts, with the help of different features, we get to know some reliable information. Like if it is a superstore data, then we will take the profits or the products which is more selling. Then we will, by taking these features and by plotting them for different columns or different features, we will get the insights that what is happening and why it is happening. And if we basically, in this part, we will just only try to analyze the data, so that we can think that which machine learning model. As in machine learning, I have already told you that there are different types of machine learning: supervised, unsupervised, semi-supervised, and reinforcement. Then we will think that which part do we need to work after this analyzation. So I think my friend is doing the analyzation, and once he will complete it with the analyzing of the data, he will tell that why we are using the classification here.
I think there's a problem with the fixed figure size. It is not
Yeah, I
correctly
think
set.
it is. We can just.
Okay, now moving on to the test data. So I just have to copy this and similarly for test data, we can have a box plot. And these black dots are the outliers which we have to tackle. Since it is it is a negligible, means the outliers, if it is beyond some value, like for example 1,000 or something in lakhs, then we have to remove that. But currently there is no point to delete the outliers, as it is simply a negligible values, as you can see below 250. Now we have plot the box plot. Now the main thing is the correlation. So correlation matrix tell us about the heat map and train data correlation. Or we can use this correlation. Oh, there's another. Okay. Uh, I think the syntax is right. Okay. Have to pass the just. Oh, I have a categorical value. So for this, I have to remove the categorical value. It's basically converting categorical value to int or float data type. So for this, I'll be using label encoder. So first we will import the schedule, then pre-processing. From this, we will get the label encoder class. So label encoder encodes the target labels with values between 0 and number of classes it contains. So for this, I'll be using plain data. And what is the categorical value here is weather condition. So I have to convert this column. So I have to pass the weather condition here. And now LE dot fit and transform. And we pass the now we can just do the train data dot info to check. See, our weather condition data is converted to the integer. So that's how the label encoder works. Suraj,
Yes.
you can tell about the label encoder class more in detail.
Yes. I will definitely tell. Level encoder, basically, with the help of level encoder, we can change our string data, a string or a classification type of data, into or integer or float data, because here we are trying to do correlation, and correlation is a mathematical function in which we need different types of in form data set in types of your integer or float. Okay, and so basically, yes, that's the all that label encoder will do. Like if you have a male female, so it will convert the m or f into 1 2 or 0 1, something like that.
I think there is some issue with the figure size. Oh, no.
Now it's clear.
As you can see, this is the heat map. Heat map tells us about the how each column is related to one another. Means how is the correlation between the, for example, month and the weather condition have a correlation value of 0.36, which is quite good also. Means above the value of 0.2 is considered as a good value for the correlation. And similarly, negative correlation is means we will not work with the negative correlated values if it is beyond 0.2. So we will drop that columns which have the which will not fit inside the correlation values. So you can talk about the correlation concept also. Suraj, fingers that tip correlation here. Okay. Since the sea level pressure contains means it is beyond 0.79, 0.7, 1.66 means sea level pressure is the for means the least correlated values with all of the columns, majority of the columns. So we can drop this. Temperature next is minus 0.62. I think rest of the column we can work with means it is following the correlation matrix. And just for now, we have removed the sea level pressure as it is least correlated with among all other columns. Suraj,
Hello.
yeah,
Yes.
you can talk about the correlation values. Means
Yes.
why is it is good to
Yeah.
have a correlation and negative correlation?
Yes. I will let you understand that correlation. It you can think it is of directly proportionate or indirectly proportionate. Whenever you have a positive correlation, then it is directly proportionate. That if something goes with something, it is good, and for negative correlation, it can be think as negative. Indirectly proportionate, like it can be better understand from an example, like if you smoke cigarettes, then your life expectancy will be less, then it's a negative correlation. And for positive correlation, you can, if you eat a healthy diet, then your life expectancy will be good, then it is an example of positive correlation. And here, as my friend has told, that he is removing the sea level pressure, because it is not helping us that much in finding. And it is, where is the sea level? Okay.
So yes, we have successfully removed the sea level pressure. We found the test it also. Now, since we have cleaned the outliers, means there's nothing like outliers in the data set. We have worked with the null values and we have seen the correlation amongst the columns and have successfully removed the sea level pressure as it is least correlated. Means it is the negative zero point 0.7, which is beyond
Yes.
the threshold value which we have set.
And yes, and here by outliners, he means the values which are too much extremes or too much low, which are not helping us that much if they are removed also.
So now we will split our data set as X contain the train data. First, we will work with the target value, which we have to achieve, which is the weather condition. This is our the target value, which we have to achieve. And similarly for X, on this, we can drop the, because in the variable, we cannot work with the output variable. So we have to drop the weather condition from the train data. access will be passed 1 as we are deleting the column. So we will pass 1, and if we deleted the row, we can pass 0. Now we have get our x and y. Now we will get some x-ray to train our model. So we have to work on the trained data only. So before moving on to, we can have the shape. Is what is the shape of the trained data since it is 634. Now we will split our x train is 80% of the value. And similarly, y train, we can have the length of y with the 80% of the value. Now the value more than the 80% will be given to the x test, and similarly for y test. Or we can just print the x tree shape. Next test shape.
Yeah, I think you can skip this part and just directly train the data.
Okay.
As we are tight on schedule.
Okay. Okay. You have to like this. We have to convert the float value to it. Means we cannot pass the float value as the slicing. Yeah. So we have the train. We have a 507 rows with 15 columns, and for the train, we have the 127 values. Now we will work with the logistic regression, as it is the best for means for the beginner classification algorithm. Now we'll just call the fit method. We will pass our x train and y train. And we will get the prediction value. So we have built our model logistic regression. That is due to because we have not passed the sample size. But we have to predict for the X test. Dot metrics. We have our accuracy score. Means which will evaluate our model based upon the accuracy score. So we have to pass the true value, which is the Y test, and the thing what we will predict. Since we are getting the 91.33, and this can be assumed as store the accuracy in a variable, and the model accuracy is, we can just pass as a string accuracy and multiply by 100. So our model accuracy is 91%. So just like this, we can train our model and get the prediction. Now I would like Suraj to explain a little bit more about the code which we have just did.
Yeah, so I will just only tell you the short description because it is, I think, that too much far into machine learning for you now. So basically, in this whole code or this hands-on session, we had just first taken the data set from the Kaggle, and after taking that data set, we had just cleaned the data for checking that null or repetitive values. And after that, after seeing some things like my friend firstly had missed the categorization, but he had later on just converted the categorization using the label encoder. And with these all things are much more useful during our data wrangling process. And after that he had just uh, analyzed the data using the correlation heat map, in which he had found that the sea level pressure is giving too much not cooperative values. That's why he had removed it, the sea level pressure. And after that checking, he had just applied the logistic regression model by splitting the data into training and testing. And at the end, the dataset which he had put for testing and the algorithm which he has trained on the training dataset, last time he will just evaluate the accuracy, and we find out that our accuracy is 91. I think it is pretty much good. And we can also, after applying logistic regression, we can also try different regression models so that we can check that how our accuracy is changing according to it. And that's all in machine learning. Yes. If you want to add something, you can add, Mayank.
Nothing much. So you would like to talk about the some LLM models you were talking before?
Yeah, I think.
Tell about the different frameworks
yes.
to apply the LLMs.
Yes. I think this is the machine learning session, so now we can restrict ourselves to machine learning.
Okay.
Or we can just show your pet project here.
I think that will be enough for today.
Yes.
Okay, thank you so much, guys, for being here, and thank you so much for to our audience as well for being such an amazing audience and for being such a keen and passionate ones to understand the session and to hear with so much of enthusiasm and excitement. Thank you for attending today's session. Now let's meet in another session that is going to happen on 3rd of March, that is in collaboration with Coding Ninjas. So see you all on 3rd. Thank you so much.